Hi everyone, welcome to AP Calculus. I'm so excited to be doing my first flipped class ever. Yay! And you are the second cohort of HSLI Calculus ever as well. So that's also yay. And since we're all new at this, we're all learning, I want to make sure we all know that it's okay to make mistakes. I will probably make some mistakes in this video. But I also would like some feedback from you. So let me know how this is working. Can you hear me? Is there anything I can be doing that will make things clearer? Please let me know. Also, write down any questions you have. Feel free to watch this multiple times, and we can discuss this tomorrow in class. So let's dive right into it. We are talking about limits. Limits is basically what y value we are approaching. So limits are the y value a function is approaching. So typically, if we have something like this, that means f of 2. F of 2 is when x is 2. What is the y value? So we go to x is 2, and we go up until we hit our graph. Our y value here is 1. So f of 2 is 1. Limits are pretty similar. Let's look at the case where x equals 1. So this notation means the limit as x the limit of f of x as x approaches 1. Okay, the limit of f of x as x approaches 1. So let's look in our graph. Here is x equals 1. If I look for the value of the function, I have a hole right here, and the value of the function is actually at the top here. The value of f of 1 is actually 2. But what does it look like it should be? What are we approaching? So if we go from the left side, it looks like we're going up to 1. And if we go from the right side, it looks like we're also going to 1. But then suddenly there's a hole and the point has jumped. So the limit is, what does it look like we're going to? It looks like we're going to the y value of 1. So the limit as x approaches 1 of f of x is 1. Let's look at another case. Let's look at x equals 3. So x equals 3 is here. We want the limit as x equals limit of f of x as x approaches 3. So here's x equal to 3. What does it look like we're approaching? Well, if we're coming from the left, it looks like we're going to 1. But if we're going from the right, it looks like we're going to 2. In this case, when we have two different things it looks like we're coming to, that we call DNE, for does not exist. However, we can clarify which side we want. So here we have this negative sign at the top. This negative tells us we're approaching 3 from the left, or from smaller x values. So what's a number smaller than 3? 2. So if we're going from 2 and approaching 3 as the x value, our y value here looks like it is 1. But if we have a positive exponent, that means we're coming from the right. So if we're coming from the right, the y value here looks like it's going to be, from the right, we're going from like a number bigger than 3, 4. Looks like our y value here is going to be 2. Now, what's the actual value of the function? The actual value of the function is where we have the dot filled in. So the actual value here is 1. So f of 3 is 1. So even though the limit does not exist, the function exists. Let's look at another case. Let's look at, I'm losing colors. Let's do blue. X equals 5. So limit as x approaches 5 of f of x. Here's x equals 5. What do you think this one is? Well, if we're approaching from the left, our y value looks like it should go to -1. If we're approaching from the right, our y value looks like it's also approaching -1. So the limit here is -1. But what's the value of the function? Well, we have a hole here, and there's no other point to fill in that hole. So the function here is undefined. So note, if the limit is defined, that does not necessarily mean that the function is defined. We saw cases at x equals 3, the limit did not exist, but the function did. And here at x equals 5, the limit exists, but the function is undefined. Now, these 3 cases show 3 different types of discontinuity. Okay? The first one is we have a hole and there's a point elsewhere. This is like a case where you and your friend decide you're going to meet up at some place to eat. Let's say you're going to the Dunkin' Donuts. Okay? You and your friend are going to Dunkin' Donuts, you decide to meet there, and you both have the same address, and you meet up. However, when you get there, there's a sign on the window that says, Dunkin' Donuts has moved. Now, you are approaching from your location to this Dunkin' Donuts, and your friend is approaching from their location to the Dunkin' Donuts. You two will meet, but the Dunkin' Donuts has moved. At x equals 5, here, each one of you is going to that Dunkin' Donuts, but the Dunkin' Donuts has closed. It doesn't exist anymore. You and your friend will meet, but there will be no Dunkin' Donuts anywhere in the world here. Well, it could be anywhere in the world, just not in this location. Now, at x equals 3, this is the case where you thought you were meeting at Dunkin' Donuts. So here, you were going to Dunkin' Donuts. You were meeting there, but your friends thought you were meeting at school. And then they're going here. Will you and your friends ever meet? No. You're going to 2 different places. So the limit does not exist if you and your friend do not meet. So I hope this is clear. If it's not, write down questions, watch the video again, and we'll discuss and practice tomorrow morning class. Remember to either bring your old calculator or money for a calculator and buy a binder or bring in a binder. And have a wonderful evening. Bye.